to everyone. So, thank you, Robert, for the introduction. Thanks to everyone who is here today to see my presentation about Diota, and also thank you to AWE that we have the opportunity to present our company, our solutions, and our use cases, and opportunities that we provide in the future to you. So my name is Sebastian Knödel. I'm the Managing Director of the Diota GmbH. And I'm really happy actually to be here. I was at several AWEs, and this is the first time that we have the occasion to present Diota and our solutions. So I think our presentation, and I hope actually, will be very well in line with what you already heard in the other great presentations that already took place, because we will, I want to try to show to you how we actually, at Diota, with our activities, move from a proof of concept to a pilot to full-scale deployment, which we actually do. And actually, that's really the direction of my presentation. So we will, in the first part, I will talk a little bit about Diota, where we are today, where we are coming from, and what are our use cases, success stories. And in the second part, I would like to introduce you to our new generation of solutions that will allow you, actually, that will enable the clients itself, partners, integrators, to benefit from our technologies that are already deployed today and adapt them specifically to their needs and deploy them with us or even alone in their environment to address their specific challenges. So first of all, I would like to say a word actually about Diota, because I'm not sure if everyone in the room knows us. So we are, initially, we are a French company with our headquarters in France, in Paris. We have another office in Stuttgart, in Germany, actually in Ludwigsburg, which I'm leading. And we are developing solutions to help industrial companies bridging the gap between their information system on one side and the shop floor workers on the other side. Today, we are about 70 people, and we have been actually, I think we are, like 18 months ago, we were only 35, so we're actually growing. So if anyone here is interested and looks for a job opportunity, I would like to say that we are looking for motivated people. If you're a developer, if you're marketing, sales, whatever, just contact me, talk to us, go to the booth 128, I think it's the booth. And yeah, maybe it fits, and we can start, you can join our journey, our adventure. So this was the first important point I wanted to make in my presentation. And something else I would like to say about Diota, because actually Diota was founded in 2009. And we had last week our 10th year anniversary in Paris, so maybe some of you have been able to attend there. And it was a great event. And so we actually have for this area of augmented reality and the startups quite a little bit of history. So and I think to quickly tell about our history and our mindset will help you also to understand where we're coming from, where we are today, and where we actually want to go tomorrow, and hopefully with you. So in the beginning, I mean, we were like 4 people, and we're developing service applications already for industrial companies, mainly in automotive sector, but we quickly started also working with companies in the aerospace sector. As you can see, there's Renault, there's Peugeot in France, there's obviously Dassault Aviation, Safran, big players in the aerospace company. So in Germany, we also started working with Volkswagen, with Audi, Porsche, and Daimler, and other companies in the energy sector. So, and when we did this at the beginning, we created basically mobile applications. So some of them use augmented reality, some of them not. But the purpose was always because all of those companies faced at that time, and I mean they still face them obviously even more, very big challenges to ramp up their production, to manage more complex configurations in their manufacturing, to while ramping up the production, guarantee and actually improve the quality, especially in the aerospace industry. Oh. And when we worked with them, we understood very quickly that one big challenge is that they face, because they have all those huge data, simulations, processes, CAD data, whatever, available on their information systems, and they had and still have actually difficulties to provide all of this information to the shop floor worker so that he can benefit from that, so then he can work more efficiently, faster, and actually maybe in a more suited environment. And that's where we started to develop solutions to bridge this gap between the information system and the shop floor. And this continues actually, and today we have a platform that allows us to deploy our solutions. And here you get a quick insight in the video how those solutions look like, and how those solutions that we deploy today can be used or are used by our clients. So as I indicated earlier, our idea is our goal is to bridge this gap between the information system and the operational world. To create also, to improve the operations on the shop floor, but also to create collaborations between this information, engineering, for example, engineering manufacturing, and the shop floor workers. So the first important step is obviously to create connectors so that the users can get access to data. And once they have it, they can use, for example, here, the visualizations of virtual data in an aircraft cockpit to see and review the different elements that are supposed to be there and might be changed, maintained, or assembled. So another use case is the visualization, for example, of work instructions during manufacturing in aircraft as well, where workers today use our, for example, projection systems to assemble parts in aircraft manufacturing, rivets, bolts, etc. Another example, for example, with a HoloLens, but our systems are completely multi-platform, can be used also on tablets, are to display and provide to workers interactive work instructions on real objects, how to assemble them, disassemble them, or maybe to maintain them. Here, for example, you have a maintenance application where the user is guided to a very particular location to maintain an electrical cabinet. And last but not least, also to actually help companies to ramp up fastly the skills of their workers, do quick knowledge transfer. And on top of that, all our systems allow to not only display but also capture data on the shop floor that can be then provided back into the engineering manufacturing, for example, so that the processes already in place and the data already in place can be improved. So this gives you a global idea what our solutions look like and how they can be used. So when I talk about our solutions, what I mean is we have two main solutions. We have the solution Digital Assisted Operator, and another solution, it's called the Digital-Based Robotics. So the Digital Assisted Operator is a family of solutions that will allow and help assist a human operator during his operations on the shop floor, be it maintenance, be it assembly, or be it, for example, quality control, by helping him and visualizing work instructions in the best possible way. For example, by projection, so that he has his hands free, we're using a tablet so that he can interact actually with the digital mock-up or the scenery that he has in place and can capture data. We also have technologies that allow to assist for automatic defect detection, so that, for example, during conformity checks, the user already gets information from the system if the state of his product, what he's supposed to work with, is correct or not. On the other side, there's this digital-based robotic system. So we have also a robot on the shop floor, at our booth that actually does automatic inspection and documentation of an engine, in this case a car engine, and both of those families of solutions can actually work together. So meaning that a robot can automatically document and capture data on the shop floor, and an operator that uses also technologies can actually assist to that, control it, supervise it. So the goal of that is obviously to increase efficiency in these companies on the shop floor, reduce cycle times, fast skill ramp up, and introduce new possibilities to collaborate between shop floor operators. The other part is increasing quality by reducing error risk, and the last element that is really, really important and becomes even more important is the traceability, the possibility to trace data, capture data, and feed it back into the information system. So as I already said, we have basically three main areas where we use our technology: in manufacturing, for example, aircraft assembly, inspection, quality control, as well in car manufacturing, pre-series center use our technology to control and verify, validate, for example, if bolts and car bodies are present or not, and in maintenance. So just to give you, in some words, an idea, so we have deployments today at Safran in line manufacturing for aircraft engines, where our systems are not only used to assist operators during assembly of the engines, but also to use those systems afterwards to verify if those assemblies have been done properly. And at the end of the line is a robot that really will actually verify if everything was put in place and the engine is ready to be delivered to the final client. In automotive, we have, as I already said, different systems in car manufacturing, pre-series center, where a lot of work still is manual, and the user can use those systems, our systems, to verify and qualify welding points, bolts, the correct configuration of jigs and fixtures that are delivered by subcontractors, or for example, big press tools and press shops. So one one example that I would like to emphasize a little bit is our deployments at Dassault Aviation, which are taking place actually already for a while. So Dassault Aviation is one of the biggest manufacturers, of military aircraft, but also of private aircraft. And we started actually working already together in 2014, I think, where they face challenges that because the whole line production is actually very manual today. So it's really manufacturing. So today, a user, a shop floor worker, takes basically instructions on paper and will then draw on aircraft panels the references for rivets, for bolts, and for other elements. So obviously, this is very cumbersome and actually is error prone, because all of this information that will pass from the PLM system is correctly available in the PLM system, has to be put on paper, then go through the operator who will draw it on the panel. And errors in this area and this are extremely expensive to repair afterwards. The later you detect them and repair them, the more expensive it's going to be. And we are talking about big amounts of very high costs. So actually, this also can show you that it is actually, for the right use case, rather easy to get benefits and return of investment. So here we proposed them a system, we installed and deployed systems that are used today in production, where all the data for bolts, positioning of bolts, references of bolts, comes from the PLM system and is projected directly on the aircraft panel, so that the worker does not need to draw on this panel, this references. So we remove the error-prone activities, and we can also control afterwards if those elements are properly installed. And as you can see, the systems are integrated in the environment of Dassault Aviation, integrated of the PLM system of Dassault Aviation, so to be as efficient as possible. So we have, I think, this is in Martignac, next to Bordeaux, where we have about 20 projectors working today. And we have other installation in lines in aircraft manufacturing or car manufacturing that also exists today. So how did we get there? So we get there by actually we have a family of different software products that will constitute the solutions that I introduced earlier. And all those solutions are, the software solutions run on different devices. We have a broad family of hardware devices that we support, workstation, projector, HoloLens, etc. And that allows us to integrate very specifically and best as possible into a specific environment. More on top of that, we have integrations into almost all popular PLM systems so that our clients can access their data easily and fast, and we provide powerful technological assets so that different activities can be supported. So why I'm here today? So I'm obviously here today to tell you this beautiful story of Diota and what we achieved, but we won't like to especially tell you that in the future you can this with us and also actually alone, autonomous. So we will provide a new generation of product, a framework that will allow you to create your specific solution for your customer and do your deployments with the customer in a way that will allow you to also adapt it to their specific needs as we do today. So how do we do it? So those are called digital field solutions. So there are actually three main challenges that are there and that we can address with our technology and that we will make available to you. So the first is a custom shop floor implementation. So as you have seen in the video, it is necessary, depending on the work that the shop floor worker has to do, to integrate in a specific way so that he does not need to hassle with the technology but can use it as a tool in a way that is as efficient as possible. So we have, as I already stated, projection, HoloLens for hands-free interaction. We have workstations or tablets for example, quality control, where you can interact with the device. And for example, in maintenance, it is very possible to have small, lightweight devices that's still powerful. So we are today supporting all popular platforms for mobile phones and tablets. And this allows to integrate with your integrator or yourself into this environment. So the next step is you need an application, a framework that you can specifically adapt so that it fits to the needs and requirements of the company. This could be, sometimes just the user experience or the guidelines that the company has to respect. It could be in the part of documentation that must be very specific. So today, we have a lot of modules which you see here that contain often also sub-modules, etc., and that constitute our Diota player, which is basically the software that is running today in all those videos that you've seen. That's one software for all devices. So as you can imagine, this is today a big pack of modules to access, handle data, connect to CATIA Composer. If you're looking for a connector to CATIA Composer, as I heard before, come to our booth and talk to us. And you can integrate render data. We have industry-specific algorithms for remote assistance. You can get automatic inspection, etc. Conformity checks are really important for quality control. And we have other technologies like, for example, tracking technology, which is essential to all augmented reality applications, where we can propose also high-end solutions. So, and the platform will allow you to actually take the modules that you need to assemble it together for the application that will finally address the need of the worker on the shop floor. So to give you an example, we have a field operator. This is a true field operator. So he's working today in aircraft maintenance and has to actually navigate through a DMU, digital mockup, which is really complex, and has to find a specific part, a connector to repair it. So this is actually not a very high-level application, but there's one very specific part of it that is, in this case, very special. So it's a huge data set. So this is like, we're talking about millions of triangles, millions and millions of triangles that need to be accessible in real time, quickly on a mobile device. So how do we do that? So in this case, for example, we take our native DMU importer, we take LODs, we take our connector API, we have a massive DMU data management. We add to that a work instruction scenario with the possibility to create reports, and we have our rendering technology that will allow him to render it quickly and fast and efficient on the shop floor while he is looking into the data set. And maybe you notice here that there is not even tracking. This is not yet augmented reality there, but this subset of modules will already allow you to create an application that might actually fulfill already tasks that can be extremely helpful for those people. And here could be, of course, the case that the shop floor worker says, yeah, but, or his manager maybe, that he wants to superimpose the information on the real object. So then you can, or we can add together tracking algorithms that will fit best to the scenario and allow you to visualize actually the data on the right place. We can add inspection algorithms that will allow to get information about the state of the element, and other modules that we can provide and make accessible. And this will allow our partners' clients in the future to adapt and integrate faster and better into their environments, which is key to deployment, which is key to moving from proof of concept to pilot and to a full deployment in an industry. And we want to share this actually with you. So, and the last, this is a rather technical slide just to give you an idea for all the people who are maybe, so our modules, what's a module? A module is actually a subset of components, technological components, algorithms with an API, and you can, top of that, create a human-machine user interface that will create a very, ideal user experience for the shop floor worker in your scenario, and you can use that in our framework and deploy it. Another example of a specific module that we will provide, or modules actually, it's our award-winning constraint SLAM tracking technology that we already use for like 7 years, probably. It's very robust, it's very accurate, it's markerless, and today available also cross-platform. We present today, you can see it at our booth 128, our new ultra mobile tracking technology. It's a tracking technology that is specifically adapted for mobile devices, phones, tablets, but also adapted for the needs that we try to address in automatic inspection scenarios. So what's missing? So we talked about the implementation on the shop floor. We talked about creating specific applications for specific use cases at specific clients. So when you have all of that, you have actually missing the most important part of it, which is basically the fuel of all of it. The fuel is the data. The data, only if the data is available, if you or your client can connect to that data, exploit it, use it, then you can use all those systems that you might have built before. So we have our Diota Connect platform, which provides also possibilities to create modules to address and integrate with specific PLM environments, for example. In this case, it was a scenario with the massive data set and LODs, etc., but it could be something different. It could be very specific work instruction processes that are important for your company. We have support for all popular industrial data formats, which can be also loaded on runtime in a very efficient way. And we also introduce now connectors for IoT. We have a connection now, as far as I know, for Desouté, which is a tool to do torque, where we can get information about torque measurements. And this all of this can be integrated and extended by you through our API and be used. So all this data that you get there is stored in our own data format, which is WI4, Work Instruction 4.0. And I would like to emphasize here that this is a data format which is open, which is platform agnostic, and which is also extendable. So the idea here is really that you remain the master of your data and actually can exploit it afterwards in different scenarios on different platforms wherever you want. And afterwards, or also in the near future, we will provide more high-level functionalities which will allow, for example, it's especially interesting for small and mid-sized companies where they can get user management functionalities, they can get communication systems for functionalities for collaboration, and actually even data storage possibilities to install this on the shop floor and facilitate interaction between the digital information system and the shop floor worker. So this was big stuff. And so now you know who Diota is, what we can do, what you can do with our technology. I talked about how you will be able in the future to do it. So now the question is how basically to do it. So just a little reminder, we talked about applications, algorithms, technologies, implementations. The tracking technology, we have connectors, we can provide everything you need to get the data, and we have, as I said already, the means to integrate with various environments. So this is a huge, big thing, and you can choose whatever you want to use to create your final application. So where the place where you're going to choose that is called the Diota App Factory, which is a framework for building industry-fitted applications for digital field solutions. So there will be a build system that will give you access to all those modules and submodules to create your application and use it. There will be a develop tool, an app builder, that will allow you to actually, if you have the capacity and the ability to develop your own modules, which you also master and proprietary, it's your property, which you can use in conjunction with our framework, our modules, our tools. And all of this can then be made available in your environment, in your company, in your group, in your line, maybe only at one workplace through an App Center access. So and this is actually what we do already today and what we are started already doing with some partners, some premium partners, now in Q4. So the Build and Access App Center will be available in the beginning of next year in Q1. And proposing this to you will hopefully help us, and you especially to address all those needs and address the challenges that the industry, aerospace, car manufacturing, energy faces today and in the future. So thank you very much for your attention. As I already said, there's a booth with a lot of demos, and 128 is the booth, and you can come there, ask questions, get more information, how this is going to work, how it works. So test it, try to break it. I'm not physically, please. And we are happy to answer any questions that you have. Thank you very much.